Today, we're going to go through chapter 3, which is about the relationship among variables. You know that the ultimate goal in data analysis is to find some form of correlational or causal relationship among variables. In logic, we cannot infer causality from correlations. But in data analysis, we try to model correlation with coincidence from correlation. So the first point is that causality is not inferred from coincidence. Okay. Our job as a data analyst is to look at the data and see if there is any relationship among these variables. Okay. And we should report these data with appropriate diagrams like scatter plots, like cross tables, to the decision makers. That's up to the subject matter expert or decision makers to establish a kind of causal relationship among variables. But logically and technically, we should never infer causality among variables. We can just say these two variables are correlated. For example, we have two axes. Suppose this one is x, lines, no lines, Control C, Control V. This one is y, okay. If x and y is related in this form, we can say these two variables are correlated if x and y go up at the same time. We may assume that there is some form of correlation among these variables. Okay, and here, when x goes up, y goes down. There is a kind of negative relationship among these two variables. Okay, and this form, as x decreases, y decreases too. There is a kind of perfect correlation between them, but this correlation is negative. Okay, so this way we can find a kind of relationship among variables, and we can report it as the kind of relationship between these two variables. But we should not say, we should never say y, for example, increases because x increases. As x increases, y increases. That's how we should interpret this diagram. But we cannot say y increases just because x increases. We should never establish a kind of causal relationship among variables. Our job, this is not our job. Okay. So that's how correlation works. In previous chapters, we discussed this distribution of a single variable, and we talked about two types of variables. Okay, categorical, and in order to report and get the summary of this categorical variable, we can measure the count or percentage, and we can also use bar chart or kind of line graph to summarize a single variable. For numerical variables, we can the summary of the central measure, like the previous that you took on Wednesday. We can report the distribution or kind of variance of a single variable, and also its shape. And we can, depending on the type of summary, we can use different type of diagrams like pie chart for percentage, line graph to monitor the trend over a period of time, and etc. Okay, so these are all about one single variable. Now in this chapter we want to see the relationship between two variables. Okay, and these two variables may be categorical or numerical. No question here. Okay. In this chapter, we just want to check the relationship among variables, different type of variables. Okay. So the primary interest in data analysis is the relationship between variables, and as I said, this is just a relationship, no causality among variables. And the most useful numerical summary measure is called correlation. The most useful graph is a scatter plot, and to break down numerical variable by categorical variable, we use side-by-side box plots. Okay, so for X, for the relationship between X category and Y cat category, we can use cross tables to see if they are related. If X or either of these two variables is numeric, and the other one, Y, is categorical, we use pivot table, or we can see the number. We can break down a numerical variable by the categories in Y. And for if X and Y are both numeric, we use correlation. Okay, so whenever you hear the term correlation or covariance, which is the other form of relationship among variables, you should know that we are working or dealing with two numerical variables. So we cannot use correlation or covariance when any of our variables is categorical. So for two categorical variables, we use cross table. With one, if one of the variables is categorical, we use pivot table. And for when both variable or all of the variable in our data sets are numerical, we use correlation and covariance. So these two terms are specific to just numerical variables. So now, let's look at the relationship between two categorical variables. The most meaningful way to examine relationship between two categorical variables is with count and corresponding charts of the count. We can measure or count the separate values of a variable and then report it in a table called cross table or contingency table. Now let's go to the first question. This table, smoking and drinking, it has three variables. The person is the number of person, which is a kind of label, a categorical, and we have two variables. We want to see if these two variables are related, or in other words, we want to see if people's smoking and drinking habits are correlated. For example, if smokers are drinkers as well, or not. So these are two categorical variables. Okay, so for smoker, we have these three categories: non-smoker, occasional smoker, OS, or heavy smoker. And for drinking, we have occasional, non-drinker, occasional drinker, and heavy drinker. This structure is called a cross table, and here we can put the total, and etc. Okay, this one is a cross table. This way we can check if there is any relationship among categorical variables. Okay, how can we count and check these categories for these two variables, smoking and drinking? What kind of function that we can use? Do you guys remember that?
COUNTIF function.
But there is a slight difference. Here we want to check two variables, and there is a kind of extended version of the COUNTIF. It is called COUNTIFS. COUNTIFS. But before that, I have to check and see how many records we have in this method. Again, we can click Control End to go to the end of the data set. We have 8762 rows, 8762. So we can use COUNTIFS. With COUNTIFS, we can check multiple criteria or multiple conditions. So again, first we have to define our first range, criteria range. We want to check the smoking. Our range varies between B 2 and B 8762. The first condition is that it has to be non-smoker, or E3. I'm going to put it like this, non-smoker. Okay. About 5,000 of people are non-smoker and non-drinkers. Let's see. Oh no, I made a mistake here. This is the first criteria, and now I have to check the second criteria. Second criteria again, this time we have to check the drinking habits. The range starts from C2 through C8762. And now we have to check the second condition on this range. And we want to check the non-drinkers, ND. make sure to put it between double quotation, or you can just put the cell number. For example, for non-drinker, you can put like DEF2. About 2,000 people are non-smoker and non-drinkers. I can copy this formula for the other conditions. And range, our two ranges are constant. Now for this one we have non-smoker, and I just need to check occasional drinker. The third condition, I'm going to copy this formula to this one. Again, ranges are the same. First condition is non-smoker, and the second condition must be changed to heavy drinker. And again, copy, paste. This time I have to change the first condition. This is going to be occasional smoker. Control C, Control V. Non-drinker. Heavy smoker. Non-smoker, this one is occasional smoker. Control C, Control V. Heavy smoker. The same for this column. For this column, we have heavy drinker and occasional smoker. And Control C, Control V. We have heavy drinker and heavy smoker here. Okay, now here we can use the AutoSum function. Control C, Control V, Control V. This one sums the entire row. Control C, Control V, Control V, and this is the total, which is the number of people. This way we can find the relationship among these variables. We can plot it in a diagram, in a line graph, insert, recommended chart. Okay. Do you guys see any meaningful relationship between these two variables, between the drinking and smoking habits of the people inside this data set? Yes? No? Please give me feedback. Do you guys see any relationship between these two variables?
I don't see any relationship with them.
Okay. Other friends, do you have any ideas about this diagram? I want to make sure everybody's following the discussion.
Yeah, I'm kind of looking at it the same way, like as heavy drinking, like and all that goes down, like so does the total and everything else. So I'm kind of with them on. I don't really see anything.
Yeah, you are right. There is no specific relationship between these two variables. If there was, the diagram would have been something kind of line, upward line. So here, this one goes down up to this point, and then again it goes up. So there is no relationship between these two variables. Okay, that's how we deal with categorical variables. The other method, now let's go to the next one. We use COUNTIFS and etc. and to define the variables. So now, relationship among categorical variables and a numerical variable. Okay, suppose we have a kind of, do you guys remember the example for the baseball salaries? We have, for example, one variable, salary. We want to see if the amount of salary differs by the gender. This problem would be a kind of relationship between numerical and categorical variable. So when we compare a numerical variable across two or more population, like subpopulation are males and females, subpopulation are different region of the country, and etc. Okay, so this way we try to break down our numerical variable by the categories. I will show you how to deal with this kind of data. There are two possible data formats, stack and unstack. The data are stacked if there are two long variables, such as gender and salary. The idea is that male salaries are stacked in with the female salaries. This is the format that we see in most of the built-in software. And we have also other form called unstack, when there are two short variables. So I will show you how to define stacked data in StatTools. Okay. This diagram on the left, you see the stacked, and this one is unstacked. It's a kind of short kind of format. So now let's go to this example, baseball salaries. In this data set, we have these variables. The one that we are interested in is the salary data set. For example, we want to see if male and female receive the same amount of salary, or if there is any difference, we want to see how much is the difference between their income. Okay, so salary is a numerical variable. Here in this data set, we don't have gender, position, gender, and etc. Okay. Let's check this data set to see if the position, whether they're a catcher, pitcher, and etc. Position affects the amount of salary if salary is dependent on the position. So we have these categories, categorical variable. We have these categories, pitcher, catcher, center fielder, and etc. And we want to see if their salary varies by their position. So first, we can use like something like pivot table for this kind of variable. The easiest way is to use the StatTools. And regarding the StatTools, I talked to the Palisade Corporation to see if we can get the license for that software. Our department, ISOM department, got license and paid over $1,000 for the workstations in WB216 room. But for your personal computers, I talked to their kind of manager, software manager, based in London. After a couple of emails, they agreed to give us the license for just this semester. After our current meeting, I will post an announcement and share with you the link to the DT suite, decision tool suite. You can download it and activate it on your devices. So after installing that software, you won't have to go to the workstation in the Miller building. You can work on install it on your devices and work at home. So that was about the StatTools. And let's go to the StatTools, okay? We want to see if there is any relationship between salary and the position, okay? Let's go to StatTools. First, in StatTools, we need to define our data set or our data range, okay? Here's our data range, okay? Now in the format, we need to select stacked. We want to see the kind of breakdown structure of the salary as a value. Can you guys see these two types? Val means value, cat means category. We want to see these values. Salary is a numerical variable. We define it as a value, and we want to see the income of the people by their position. Position must be defined as a categorical variable. And we can get different kind of summary statistic. Suppose we just get the mean to see if the mean salary for different positions is the same, or if it is different, how much is the difference. For baseball players, other percentile, no, we don't need. Now we just want to compare these categories. Okay. For example, here is the result. You see that the minimum or average salary for a catcher is $2 million, $2,697.49. For a center fielder is $4 million. For hitter is $8 million. I'm not sure if it is million or $1,000. And for first baseman, the average salary is $8 million. Left fielder is $5 million, and etc. Okay. Apart from these numbers, they may be correct or incorrect. We don't care about that. That's how we deal with these two types of variables. If you want to see the relationship between a categorical and a numerical variable, that's the way we can run a test and also model it in a StatTools. And we can do the same for the gender and also for the other categories. For example, if salary, how salary distributes among, for example, categories like league, whether they are in National League or American League, and etc. Okay. Questions so far?
I don't have any questions.
Yeah, go ahead. Oh, you said you don't have any questions. All right. All right. As I said, I will share the link to the StatTools and DT suite with you at the end of this meeting. And please download and install it on your machine, and then activate it on your machine. Make sure you have it until the end of the semester, as we will be using this software tool a lot during the semester. That will make your work much easier. Instead of typing the functions and etc., we can simply, just by clicking a button, we can get a kind of comprehensive report from our data set. So that's all for today. We have covered the relationship between categorical variables, two categorical variables, and a relationship between a categorical variable and a numerical variable with StatTools. And next week, we will go over the correlation and covariance, which are specific to the numerical variables. And we will work with different types of functions and techniques. So I've uploaded all the data files. You can practice and work with data sets at home. I encourage you to work with both functions, Excel functions, as well as this built-in software. And if you have any questions, please send me an email.